Hi, I'm Chase Middleman, and I'm going to be talking about using Google's BERT model to tackle problems in sentiment analysis. So what are the problems we're gonna do? Two tasks. The first is going to be positive, negative sentiment classification for Amazon product reviews. And the second is going to be chat analysis of the popular live stream platform Twitch.tv. Okay, so before we get into that, well, what is BERT? Well, it stands for bidirectional encoder representations from transformers. It's a complicated natural language processing model developed by Google into several stacked encoder layers. And if you get anything out about this, know that you don't need to know exactly how it works in order to use it in what's known as transfer learning, where we take a model that someone else made and adapt it to our specific needs. I will say it's a masked language model, which means it learns by filling in the blank on the data it's being trained on, so it takes word context into account. And it was trained on a lot of word data. Pretty much any book you've read or any Wikipedia article you've read, BERT's read as well. There's the original BERT paper there if you'd like to see more about it. But with that said, let's go to our first task, Amazon review sentiment. So what does the data look like? 4 million Amazon.com product reviews from a Kaggle data set. Each is labeled positive or negative, not stars, just positive or negative. The data set is balanced, 50-50 negative. What's the main holdout with training on this data? Well, it's slow. There's a lot of data, 4 million Amazon reviews, nearly 500 million words. In addition to that, the model BERT itself that we're using, the layers are all unfrozen, meaning that we're training on all 100+ million parameters. There are even larger versions of BERT that have 300+ million. This takes time. So for example, per epoch, one pass through of all 4 million Amazon reviews. On a CPU, this takes over a week. So that's not going to cut it for us. By training on graphics processing units, we were able to get the training time down to 20 hours per epoch, which is good. But hey, what if you want to do multiple epochs, and good luck searching the hyperparameter space at this rate? So to really give it the juice, we use Google's state-of-the-art tensor processing units, and we got the training time down to 2.5 hours per epoch. Now, we did run into some issues with pickling the trained model for production, but workarounds were found, as we will see at the end of this presentation. Okay, well, so what about the results? Now, something baseline to compare it to is an out-of-the-box BERT transformer by the Hugging Face platform. Now, without training on the Amazon reviews at all, this model was able to get 90% language and then seeing Amazon reviews and classifying them as positive or negative. But let's do a lot better task-specific BERT model, which was trained on all this Amazon reviews data. We achieved 97% accuracy. That's a 70% decrease in error. And we got this after training on 3 epochs, 3 pass-throughs of the data, after which overfitting began to occur, so this is where we cut it. I will point out that we had a symmetric confusion matrix, meaning of the 3% of things that it did misclassify, it wasn't really skewed in one direction or the other. It was missing sort of equally. And we can take a look at some misclassifications here. Now, in a lot of them you see, they'd be pretty hard, even for a human, to get right there. I'll say the one on the bottom, a human could probably figure out that that is indeed a positive view. And in fact, BERT did as well after the spelling errors were corrected. And so that gives us an idea of, maybe where we could go next to try and get some more juice out of it. All right, well, with that being said, let's go on to our second task, which is Twitch chat emote analysis. So for those of you who don't know, Twitch.tv is a live streaming platform that connects a streamer with an audience. And the audience communicates through Twitch chat, which consists of text and also these pictographic symbols that are called emotes, which depict sort of emotions in some sense. And together, the streamer and the audience, they have a shared experience. Now, this particular streamer is named XQC. And some who watch him may come to the conclusion that he's a whiny, immature man-child. To which I say, irrelevant. What matters is that every time he logs on, over 60,000 people watch him. That's value. Okay, so as we said, Twitch chat can be broken down into text and emotes. Now, prior work doing classifying Twitch chat sentiment, which has been done, tends to separate the text and the emotes, classify the sentiment individually of each, and then combine them to get some kind of net sentiment. I've come to the conclusion that's the wrong way to go about analyzing Twitch chat, which leads me to the fundamental, somewhat psychological assumption I'm making here, which sort of leads the rest of this. And that's that the collective sentiment of Twitch chat is directly captured by the emotes used in that channel. And that on average, the sentiment of chat text can be captured by the emotes that they are surrounded by. This turns the task into a supervised learning problem where the labels for a given comment are given by the emotes that surround it, with higher weights being given to emotes that are much closer to the comment time-wise. And that's sort of the weight decays as it falls off either forward or backwards. So let's see how it did. Well, similar training paradigm to before, trained on tensor processing units. So I won't go into it too much. We trained on 1 million chat comments from XQC streams. And after that, we ran on a collection of 500 comments, about 40 seconds, from when he was watching a coronavirus vaccine debate, compared to just an average of a random sample taken from his chat across all streams. And I guess I'll point out that there were decreased levels of lol, which one might expect from, you know, a vaccine debate video. There were increased levels of cursed. Now, cursed is, in this case, an XQC stream-specific emote, as opposed to lol, which is a global emote. Now, there was also, what kind of surprised me a little bit, that there were not significantly different levels of Kappan, an emote that represents sarcastic sentiment in Twitch. This is just to give you an idea of, you know, the start of some things that could be done with this. I think another very feasible and interesting thing to apply this to is for when streamers are reading sponsored ads, and to gauge how their chat is reacting to them reading the ad content as compared to typical content. I think after doing this a lot, I've come to the conclusion that there's certainly money on the ground. It's just a bit tricky about how we're going to get to it. And with that, before we get a demo, I would like to thank you all very much for coming. I appreciate your time. And yeah, so let's open it up to Q&A, as well as a demo of the Amazon review classifier. So for example, while I take questions, feel free to type them in the chat. Feel free to also type in a potential Amazon review product. For example, this product is great. But see if you can beat it by maybe picking something that doesn't use words like great or terrible. As an example of regional diction that is pretty impressed that BERT has, if you're from Philly, you know that the statement, "this John Drawlin," well, that's negative. If you're not from Philly, you probably have no clue what that means. But in fact, BERT does not have a problem making sure that's negative. I have some more examples I think would be cool to type in, but maybe I'll give y'all a shot. All right, let's see how Rob's does. I'm assuming that's going to be positive, Rob, and well, BERT thinks so at least. Okay, let's try I like fish. Okay, it's not super sure, but it seems to be on the slightly more positive side of things. Returned tends to be a negative one. I used to enjoy this product, but now I don't. You want to? All right, let's try with that. Let's try with just this, but maybe I'll put, but now I don't. Oh, well, there you go. Yeah, I'm always surprised by how amazing BERT is. And after reading 4 million Amazon reviews, it kind of knows the gist of what people tend to say. I do see a question up at the top there from Ms. Ford. Have you thought of applications in ad tech for this? Well, yeah, so that was, I did mention that on the slide of, yeah, if you could somehow use this to get the emotional sentiment of chat, or however they're reacting, compared to how they're normally reacting, or compared to how they're reacting when, you know, the streamer does something very cool or very interesting, then you could see, yeah, the engagement of how they are reacting when a streamer is reading that ad content. Thank you, Yang. I appreciate it. Or maybe that you were being serious, and I'll try it. Okay. BERT's 99.4% sure that the work is epic.
All right. Do we have any more questions? We have time for one more question, I believe. Someone has one.
Chase, I have a question. What was the hardest part about actually like creating this application section of your project? Like what, you know, web hosting and design and all that, what do you think was harder?
Well, what ended up being the most tricky thing actually was for tensor processing units. One, it took some steps to be able to train the model on these, because they're being trained in Google Cloud tensor processing units. So to be able to get the model to be trained there. Then when it became time to get this model into production for this website, the model did not want to come along for the ride. It wanted to stay a tensor processing unit thing, because on this website, it's only running on the CPU, which is why I wanted to have an example for this being applied to Twitch chat, where you would see Twitch chat going by and then it would sort of like be classifying it. With XQC's chat, it goes way too fast for it to be able to process on a CPU. A GPU could do it in this case. But anyway, after training on the tensor processing units, it didn't want to come along for the ride, and it took a while to sort of unpiece how to do it. But as I said in the presentation, it was eventually found how to do it. And so this is the model predicting on the CPU, which is slower, but it can handle one thing at a time, no problem.
Cool, thanks.